Hello, welcome back to Untitled Maths. In this video I'm going to be going through some practice questions to do with the exponent laws. You can find my videos on the laws themselves in the playlist in the description down below. As always, make sure to pause before I go through each question and have a go at it yourself. Remember to like and share this video, subscribe to my YouTube channel and leave a comment with any requests for topic questions or any feedback. The first question reads 4x to the power of a half times 5x to the power of minus 3 over 2. Make sure to pause the video and try it yourself. When you see the half power, it might seem tempting to rewrite this as 4 root x. However, you'll find that in the context of the whole question, it's usually best to leave roots till the end and try solving the exponents and simplifying them as much as you can first. Firstly, it's always best to try and multiply out the constants first. So multiply 4 times 5 to get 20, and this will be your coefficient for the answer. Next, since we're multiplying expressions with powers in them, think back to our first rule, which said that if you multiply two powers, your result is the base raised to the power of the sum of those two powers. This means that here, our answer will be multiplied by x, which is our base, to the power of 1/2 plus minus 3 over 2, since that's the sum of our two powers. You can rewrite this as 20 multiplied by x, and then work out 1/2 plus minus 3 over 2. Since we're adding a negative number, this is the same as subtracting. So this is the same as 1/2 minus 3 over 2, which is equal to minus 2 over 2. And then simplified further, we can rewrite this as 20 times x to the minus 1. Now thinking back to rule number 5, we can rewrite this as 20 times 1 over x. Since our exponent is minus 1, this can be rewritten as 1 over x to the power of 1, which is really just 1 over x. And now it's simply a case of multiplying this 20 by the fraction 1 over x to get your final answer of 20 over x. Some of you may have made the mistake of writing this as 20x to the power of minus 1 and then rewriting this as 1 over 20x. This is why I find it best to write the 20 separate away from your term with the base and the exponent, because in this way it ensures that you don't get it confused with the whole term and you don't apply an exponent law to the whole thing, as incorrectly done on the right here. Before I move on to the second question, pause the video and have a go at yourself. Now thinking back to our third rule, we can rewrite this as the square root of 4 over 49 cubed. Remember that this rule says that we take the root of the denominator before raising it to the power of the numerator in the fraction. Here the denominator is 2, so we take the square root, since that's the second root, before cubing it or raising it to the power of 3. To take the square root of a fraction, we take the square root of the top and then the square root of the bottom before we cube the whole thing. So this is equal to 2 over 7 cubed. Now thinking back to rule number 6, to raise a fraction to a power, you apply that power to the numerator and then to the denominator separately. So this is equal to 2 cubed over 7 cubed, which is equal to 8 over 343. And this is our final answer. Another way to solve this question is to leave the cube inside the square root. However, this will lead you to a much longer calculation, since it'll take a lot longer to calculate 49 cubed, rather than just cubing your answer that you're left with at the end. Before I move on to the third question, pause the video and try cracking it yourself. Firstly, thinking back to rule number 5, to get rid of the negative exponent, we just take the reciprocal of that expression. So here, because it's a fraction, we'd rewrite this as y cubed over 27 to the power of 1/3. Since we've taken the reciprocal of this fraction, we can get rid of the negative exponent. Next, thinking about rule 8, when you're raising a base to the exponent in the form 1 over m, where m is in the denominator, you can rewrite that as the mth root of that base a. So here, we can rewrite this as the cube root of y cubed over 27. To evaluate a cube root, you take the cube root of the numerator and then the cube root of the denominator separately. So this is equal to the cube root of y cubed over the cube root of 27. The cube inside the cube root cancels out, so this is just equal to y, and the cube root of 27 is equal to 3. So this is our final answer. Another way to solve this would be to take the cube root first, leaving the negative 1 exponent, before taking the reciprocal of the fraction after. I prefer trying to eliminate all of the negative exponents first, because it makes looking at the equation and understanding it much easier. In the fourth and final question, we're asked to simplify the fourth root of x to the power of 5 times x to the power of 8 divided by x to the power of 3 times x to the power of 2. Make sure to pause the video and have a go at this problem yourself. In almost any problem, it's usually easiest to simplify the indices as far as you can within the root symbol before applying that root at the end. If you take the root early on, that just makes the whole problem appear a lot more messy. Thinking back to rule number 1 for multiplying powers, here we can simplify the denominator as x to the 13th power divided by x to the power of 5. We can do this because since we're multiplying the same bases, we can add the powers here. So we get 5 plus 8 equals 13. And we can add the bases again here, giving us 3 plus 2 equals 5. Since we're dividing exponents here, we can use our second rule to realize that we can just subtract the second exponent from the first since the bases are the same. So we can rewrite this as the fourth root of x to the power of 13 minus 5, which leaves us with the fourth root of x to the power of 8. There's a few different paths or routes which we can use to end up solving the problem from here. Firstly, we can realize that since we've got a fourth root over here and an 8 over here, we can cancel a 4 here, which cancel the whole root over here to leave us with 1, and divide by 4 here to leave us with 2, leaving our answer as x squared. Another method is to use the inverse of rule number 3, which states that a to the power of m times n is equal to a to the power of m raised to that n. So we can rewrite this x to the power of 8 as x to the power of 2 times 4. This can then be rewritten as x to the power of 2 raised to the power of 4. Since we're taking the fourth root and we have a power of 4 inside, these cancel out, leaving us with x squared. Finally, you can use a combination of these two methods, although it is much longer. You can rewrite a fourth root as a square root of a square root of x to the power of 4 squared, again using our rule number 3, and then the square roots cancel out here, so you're left with the square root of x to the power of 4, and again using the same method, we can rewrite this as x squared raised to the power of 2 again, cancel out the square root again, leaving us with just x squared. But the first method is definitely the most easy and also the most efficient. If there are any other problems on indices that you'd like me to cover, please mention them in a comment down below and I'll make a video going through them. Remember to subscribe with post notifications turned on so you never miss a future upload. Thank you so much for watching.